Welcome back. In this video, we are going to solve problem 12-45, and this problem is taken from chapter number 12, Deflection of Beam and Shaft, and book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the deflection at each of the pulleys C, D and E. The shaft is made of steel and having diameter of 30 millimeter. The bearing at A and B exert only vertical reaction on the shaft, and E of steel is 200 gigapascal. So you can see this is the shaft where pulley C, D and E exert force of 150 Newton, 60 Newton and 150 Newton respectively. And this is the bearing at point A and B which exert only vertical reaction force. So you have to determine due to this loading it will deflect like this. So you have to find deflection of C, deflection of D and deflection of this E. So let's start with the solution. So when you remove this bearing at point A, so you will be having a reaction force that will be acting down upward. So this is RA, and if you remove this bearing at point B, so there will be a reaction force which is represented as RB. So we'll find this RA and RB using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point A is equal to 0, taking the counterclockwise moment as positive. So about point A, one moment is due to 150 load into perpendicular distance which is 250 millimeter. So in meter it is 0.250 meter, and this is clockwise, so it will be negative. The second moment will be this one, 60 into perpendicular distance is now 500 millimeter which is 0.5 meter, and this is also clockwise, so it will be negative. The third moment will be this 150 Newton and perpendicular distance is 750 millimeter which is 0.750 meter, and this is also clockwise, so it will be negative. The last moment will be due to this force into perpendicular distance is 1000 millimeter which is 1 meter, and this is producing counterclockwise, so it will be positive. And the sum of all this moment about point A will be equal to 0. So I will write minus 150 into 0.250 minus 60 into 0.5 meter minus 150 into 0.750 meter plus RB into 1 will be equal to 0. So when you calculate it, you will get this RB will be equal to 180 Newton. Okay. So now we'll find this RA by using another equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So RA is upward, so RA minus 150 plus 60 plus 150 minus 150 minus 60 and minus 150 minus 60 minus 150 plus 180 is equal to 0. So you will get RA will be equal to, again this will be the unit is Newton, so RA will be also 180 Newton, because 150 is 300, 360 minus 360 plus 180 will be 180. So now you have RA and RB. So what we will do is that we will find equation of elastic curve, because we have to find deflection. So for that we need equation of elastic curve that can be obtained by using this equation moment, and we will find this moment by using singularity function. M can be found by using singularity functions, or you can also say it as Macaulay's method. So for that we need table that is available in the chapter number 12. So I will copy it from the previous problem which I have solved. So let me copy it and we will paste it over here. So you can see here all the loadings are points loading. So you can see these are the points load. So we'll start from the left hand side and we will count each force except this one. We will ignore right hand side. So this is the loading for point loading, and the moment equation is this one. The load is upward, so moment is positive. So I will write moment. The first force is RA, which is 180, and this is upward, so this moment will be positive. So RA is 180 into x minus A. A is 0 for RA, so x minus 0 power 1. Now we'll move toward second force, which is minus 150. So this movement will be negative, because here the movement is positive for upward. So for downward force it will be minus. So 150 into x minus, now A is 250. So 250 in meter is 0.25 power 1. The third force is 60 Newton. So that is downward. So minus 60 into x minus A will be for that 500, so which is 0.5. And the fourth force is 150, that is also downwards. 150 minus 150 into x minus A is now 750 millimeter, which is 0.75. And we will neglect the last term. So this is the moment equation. Let this is your equation number A. So what we will do is that put value of m in equation A. So you will get E into I d square V over dx square will be equal to 180 into x minus 150 into x minus 0.25 minus 60 into x minus 0.5 minus 150 into x minus 0.75. So integrate this equation, integrate it, you will get EI into dV over dx will be equal to 180 x square over 2, which is 90 x square, minus 150 into x minus 0.25 whole square divided by 2. So 150 divided by 2 is 75. So it is x minus 0.25 power 2. And this will be minus 30 into x minus 0.5 power 2. And this will be minus 150 into x minus 0.75 divided by 2. So again this will be minus 75 into x minus 0.75 power 2. Plus there is a constant of integration, which is C1. Let this is your equation number 1. What we will do is next is again integrate equation 1. So you will get EI into V is equal to 90x cube divided by 3, which will be 30x cube, minus 75 into x minus 0.25 whole cube divided by 3, and that will be equal to 25 into x minus 0.25 whole cube minus 30 into x minus 0.5 whole cube divided by 3, which is equal to 10 into x minus 0.25 whole cube, and this will be equal to 75 minus 75 will be 75 divided by 3 will be 25. So 25 into x minus 0.75 whole cube plus C1x plus C2. Let this is your equation number 2. Now C1 and C2 are unknown constant of integration. So we will use boundary conditions. Will be used for finding C1 and C2. So first boundary condition is that at x is equal to 0, we have deflection is equal to 0. So let me show you over here. You can see at point A here x is equal to 0. So we have deflection is equal to 0 because there is journal bearing or support. So put in equation number equation 2. So we will get EI into 0, and this will be equal to 30 into 0 cube minus 25 into 0 minus 0.25 cube minus 10 into 0 minus 0.25 whole cube minus 25 into x minus 0.75 whole cube. X is 0 plus c1 into 0 will be 0 plus c2. So you can see that this will be equal to 0 and this will be also 0 minus 0 minus 0.25, and that is inside the Macaulay bracket. So anything that is negative inside Macaulay bracket will be 0. Similarly, this will be 0, this will be 0. So it means that C2 will be equal to 0. Now you have C2 is equal to 0. We will use another boundary condition, and that boundary condition is that at x is equal to 1000 millimeter, or that is equal to 0.1 meter, we have deflection is equal to 0. So let me show you here. You can see x is 1000 millimeter, or that is 0.1 meter. We have deflection is equal to 0 because there is a bearing or support at point B. So what we will do is that put in equation number 2. Let me show you. This is equation number 2. So I will write EI into 0 is equal to 30 into 1, 0.1, 0.1. Okay, 1000 meter is 1 meter. 1000 millimeter is 1 meter. Let me correct it over here. So that is 1 meter. So 30 into 1 minus 25 into 1 minus 0.25 whole cube minus 10 into 1 minus 0.25 0.25. Let me check it over here. Okay, I had a mistake. You can see this is 0.25. So this is 0.5. So this is 0. Correct it. This is 0.5. So this was also 0.5, but that is negative. Okay. So 1 minus 0.5 cube minus 25 into 1 minus 0.75 whole cube plus C1 into 1, which is C1. Okay, now it's clear. So we will get 0 is equal to 30, and this term will give you 1 minus 0.75 will be 0.75 whole cube, and this will give you minus 10.55 minus this term will give you, when you calculate it, will be 1.25, and this term will give you, this whole term will give you minus 0.39 plus C1. So from here you will get C1 will be equal to minus 17.8125. Now you have C1 and C2. What will that is? Put value of C1 and C2 in equation number 2. So you will get EI into V is equal to 30x cube minus 25 into x minus 0.25 whole cube minus 10 into x minus 0.5 whole cube minus 25 into x minus 0.75 whole cube plus C1 is minus 17.81 into x plus C2 is 0. And if you divide this equation by EI on both sides. So what we will get is that we will get this term divided by EI. And that is your required equation of elastic curve. Now we will move to find VC deflection at C, D and E. So for VC we have X is equal to 0.25 meter. So first we will find VC. So VC will be at X is equal to 0.250 meter. So put it in this, let this is equation B. Put in equation B. So you will get VC is equal to deflection at X is equal to 0.25, clear, and that will be equal to 30 multiplied by 0.25 cube minus 25 into 0.25 whole 0.25 minus 0.25 whole cube minus 10 into 0.25 minus 0.5 whole cube minus 25 into x minus 0.75. X will be replaced with 0.250 minus 0.75 whole cube minus 17.81 into 0.25 divide by E into I. So the value of E is given as E for steel is 200 gigapascal and diameter is given. So 200 into 10 raised to power 9, and I for this circular pipe is pi by 4 r power 4. So diameter is given as 30 millimeter, so radius will be equal to 15 millimeter. So and meter is it is 0.0150. So 0.015 power 4. This term will be 0. This term is negative, so anything inside the Macaulay bracket that is negative will be 0. This term will be 0. So we will left with this term and this term. And when you divide it, you will get VC is equal to V at X is equal to 0.25 will be equal to minus 0.000501 meter. Or you can say that deflection at pulley C will be equal to minus 0.0001. So it will be minus 0.5 in millimeter. It is 0.501 millimeter, and you can also 0.501 millimeter, and the deflection negative means deflection is downward. So this is deflection at point C. Now we will move toward point deflection at pulley D. So X will be equal to 0.50 meter. So we will find deflection. VD at X is equal to 0.5 meter. So V is put in equation number B. So you will get VB is equal to V at X is 0.5 will be equal to, you can just put the value, I will put 130 into 0.5 whole cube minus 25 into 0.5 minus 25 0.25 whole cube minus 10 into 0.5 minus 0.5 whole cube and minus 25 into 0.5 minus 0.75 whole cube minus 17.81 into 0.5 divide by whole, we will divide it by E into I. So E is 200 gigapascal, so 200 into 10 raised to power 9, and I for circular rod is pi by 4 R4, so R is 0.015 power 4. So when you solve this, you will get VB is equal to minus 0.0000698 meter, or you can say minus 0.698 millimeter, or 0.698 millimeter, and that is downward. So this is the deflection at point B. What we can do is that we have to find deflection at point E. So here x is equal to 0.75 meter. So what we will do is that VE is equal to V at x is 0.75 will be equal to, you can just put the value, this is your assignment, you can just put x is equal to 0.5 over here, over here, over here, over here, divided by EI, and you can calculate V, that will be minus 0.501 millimeter, or you can see 0.501 millimeter, that is downward. So negative sign means that deflection is downward. You can easily solve this last part, just put the value, and I hope that you will solve it. And that was all about this problem 12-45. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also, the links of all playlists is present in the description box, so you can go and click your desired chapter and you will get all the problems of that chapter. Thank you for watching.